Hey guys, welcome back to another lesson. Today we're going to talk about transformations of quadratic graphs. Now, what I had uploaded for you originally before this lesson was a little bit of an exploration activity. Okay, so you had to explore what type of transformations were happening to some of these quadratics, and they were written in this format here. Okay, today in this first part of the video, we're going to review just real quick what those transformations were. And then we're going to start figuring out, okay, how can I make my normal quadratic into this guy right here, okay, which we call vertex form. The second part of the video, we're going to then come up with this formula given the graph, okay? We're going to try to do both parts in one lesson. I think we can do this. So up here, we have what this is called vertex form, and this is what you guys were experiencing in that exploration activity, okay? The A value, we noticed, was giving some sort of vertical transformation. Okay, so that was what? It was either being stretched or compressed, depending on what the value was, right? Stretched means that the A value had to be, what, greater than 0? Actually, specifically, I'm sorry, greater than 1. If it was compressed, it was between 0 and 1. That's when you had a fraction, okay? And we also have the fact that when it was negative, when the A value was less than 0, it was reflected, okay? It had some sort of reflection going on, going across the x-axis. That's what the A value did, and that's what you guys were discovering. Now, let's take a look at what did this H value do? Well, when negative, it gave us a horizontal shift to the right. Okay? If this was -5, that means I moved my vertex part, because anytime we did a transformation, we're always moving the vertex. I moved it to the right by 5. When this was positive, okay, it was a nice horizontal shift to the left, okay, by ever how many units. In other words, this would be positive because if I plug a negative in, it would change it. But regardless, if it was a positive number, we'd be going to the left that many units. It's kind of backwards in a way, but if you look at the XY table, you can kind of see what that behavior is, which once again, relating back to the activity, we were talking about that. And the last part, this was a vertical shift in your graph. So inside the parentheses, I took my vertex of that parabola, I was moving it left and right. This guy says, okay, once you're done with that, now take that vertex and move it either up or down. If this was positive, we moved it up. If this was negative, we moved it down. Okay? So this vertex form is pretty critical, don't you think? It tells us what this quadratic is going to look like. We can also solve with it, right? Remember when we completed the square? Okay, we did this. We actually moved our original quadratic, which looked like this, mind you. Okay, we started there. We completed the square to where it looked like this. Then we set it equal to 0 and then solved for the roots. So we're just doing the same thing, essentially. We are completing the square again. Okay? What do you think? Questions? It's a lot of information here, isn't it? It just kind of shows you how critical this guy is. All right, example 1. Are you ready? You better be ready. Okay, so, goodbye. So long. All right, example 1. Y equals x squared minus 2x plus 4. Okay, and our goal is to take this guy and write it in vertex form. Okay, in fact, can I leave it? Yeah, I think I leave it like that. In other words, we're going to complete the square but not solve it, because realize there's a y here. All right, there's no 0, so I'm not solving anything. So for my first step, we're just going to group the variables together. Okay, and the constant just kind of hangs out. And the goal was I wanted to make this guy a perfect square trinomial, right? So we talked about this. You take half of this guy and you square it. So half of -2 is -1. Squaring it gives me a +1. Okay? The only issue we had with this, and we talked about in the previous lessons, now this does not look like this anymore. I added a number to it. It changed the graph. I don't want to change the graph though. To make sure that doesn't happen, if I'm adding one, I'm going to subtract one on the outside of it. Therefore, they cancel, right? If I get rid of these parentheses and combine everything, I am going to get that original. Now we're going to factor this guy. So factors of 1 that give me -2 would be what? -1, -1. And we know that it's going to be the same, right? This is x minus 1, x minus 1. I condensed it. On the outside, we get +3. We're done. That's it. That's the entire part of it. Less work than solving it, huh? But that's okay. This is all I wanted. Now, let's go ahead. Now, it's in vertex form. Let's talk about the transformations. Inside the parentheses, I can see that there's a -1. That means I'm moving to the right by 1 unit. So it's a horizontal shift right 1 unit. Okay, that's one transformation that's happened to this guy. Now, this number on the outside, we know that gives it a vertical shift. If it's positive, that means we're going to move it up. So this would be a vertical shift, okay, up 1 unit. Okay? And that's it. That's the entire transformation part. The A value is 1, so that means it's going to be opening upward, but it's going to be a normal sloped type of parabola. We won't really have to worry about anything in terms of compressions or stretches for that guy. If I was going to graph this, we'll just do a quick graph down here. We're going to go over 1 and then up 1, 2, 3. So there you go. There's my vertex. And then we're going to draw my little arrows there. Rough graph, but we could at least see what this looks like. Solutions? No. No real solutions to this guy. There's only imaginary solutions. Another benefit to actually using this format, right? If I was to set this equal to 0, I should be expecting i's in my answers. There's going to be some complex numbers to this. One final thing. Let's talk about the vertex. And I didn't talk about it here because I wanted an example to go with. Okay, vertex. My vertex at this point is at 1, 3. There's my vertex. Now, take a look at the vertex form here. Why do we call it vertex form? See how these two numbers give me the vertex? But there's only one difference. This is now positive. We changed the sign. Okay? That's the difference to this. You got to be careful with it, okay? The 3 didn't change, right? If I look at the actual transformations itself, that confirms why this is a positive now, right? So sometimes it helps just to graph it, or maybe in your head visualize where it's at. That way you know if this is positive or negative. Now, if I were to change this, make that a positive instead, for one thing, this is now going to the left 1, right? But the other thing is this would have to be a -1 to match what the graph is. Does that make sense? Okay? So let me just put this back. There we go. So the reason why it's called vertex form, because this is the vertex. These two numbers here. Over here, let's finish it. So therefore, vertex is going to be your H value and K value. I'm going to put a little star here. Okay. Careful with the sign of H. Okay, that's very important. It just depends. If this is positive, then H will be negative. So it's always going to be the opposite of your H value, the sign of it. Okay, that's it. Any questions? Nah, I think you guys are good. Let's do another example. Say goodbye to this guy. Example 2. Let's see if I can find it in my network of papers. Oh, there we go. Okay, let's try this guy. Okay, this. Oh. There we go. Okay. Now, I know what you're thinking. There's a number in front of there. There's going to be fractions. I know it. This is going to be a long problem. I'm not going to do it. Just forget it. We're going to move on. Don't you dare say that. Don't you dare. Don't click stop on this video, okay? You can do this. This isn't bad. In fact, I made this one nicer, okay? First step, go ahead and group the variables, right? Okay. So let's go ahead and do that. Now, before I make this guy a perfect square trinomial, that -3 has to be factored out, right? That's allowing us to do so. Now, when I divide by -3 here, I get an x squared. -3 divided by this guy will give you a positive 6x. Okay. Now everything's factored out perfectly. We're good to go. Now for my second step, okay, I want to figure out what makes this a perfect square trinomial. We take half of this guy, which is 3. If we square it, I get 9. So a 9 would be put here. Now, the big part. This is no longer this guy, right? I added 9 to it. It's a different equation. I got to subtract that number out, right? But it's not 9. If you remember from previous lessons, which hopefully you do, hopefully, please. This isn't a 9. This is technically a -27, So I'm going to subtract a -27 to keep things in balance. Now be careful, you're subtracting a negative. That's going to come into play when we simplify some things. All right, so now let's go ahead. The factors, remember they're the same because it's a perfect square trinomial. It's half of this guy, right? It'd be x plus 3. Okay. And then on the other side, what's 4 minus a -27? We get a positive 31. Okay. And there's my vertex form. Now, I'm not going through every single step why this works because I have previous lesson videos on that, so make sure you watch those. I'm not going to go into every single detailed step because we should know that by now. Okay? Transformations, what's happening here? Well, let's take a look at the -3. The negative part means it's going to be reflected. Okay? For that x-axis. It's also, but that 3, is it going to be vertically stretched or is it going to be vertically compressed? Well, with a 3, it's going to rise a lot quicker. So technically, it's going to be what? A vertical stretch. Okay? Now, let's look at this guy. The +3, inside the parentheses, we're moving it left to right. +3 means we're going to move it to the left by 3. Okay? So I'm going to say left by 3. I'm not going to say horizontal or vertical. I'm saving some time with that. The 31 means I'm going to then take my vertex and move it up by 31. Okay. Now, what's my vertex going to be? So when I'm done moving it to the left 3 and up 31, my vertex, which I'll just put V there for vertex, is going to be what? -3, positive 31. That's where it's going to be located. And you can draw a quick graph, right? If I'm going to go to the left 3, 1, 2, 3, I'm going to go up by 31. Let's pretend that's 31 for right now. There's my point. It's going to be moving downward, a little bit narrow because it's being vertically stretched. So does this vertex right here match the graph? Yes. Okay. And that's it. So there's an example when you have a value in front of here and when you don't have a value in front of there. Okay. Could you get fractions here? Yes, you could. It can happen, and that's fine. I don't want you guys to ever panic on that. Okay. Pretty cool, huh? It's so amazing to think about this. We started here at the very beginning of this chapter. You were graphing this using an XY table and using that -b over 2a to find the vertex, plugging it back in to find the y coordinate. That took time, and it wasn't very efficient at times, depending on what the quadratic was. Progressing forward, we start talking about factors. factoring and how factoring can help us graph. Then we start talking about completing the square and its benefits. Then we used completing the square to find quadratic formula, which was another benefit, right? Which delved into complex numbers. And now completing the square is giving us this vertex form, which we can use to graph this a lot quicker. And let's say I want to solve for 0. I can, or I'm sorry, solve this guy for the x values. Make this 0 and solve it, which is what we did with completing the square. Everything's kind of coming up. So you started at the bottom rung when it came to the skill set with this, and now look at where you're at. It's incredible. It's fun. I mean, this is really cool how everything connects. There isn't like a separation between concepts. Everything is connected in this chapter, and I'm hoping that you're seeing that. Okay. I have 2 more examples. We're at the 15-minute mark. Well, 16 minutes almost. I think we have enough time for these 2 examples. So what else could happen? Well, I'm glad you asked that because there's always other things that can happen, right? Let's do example 3 next. All right. Let me give you a graph, and then using the graph, you have to come up with the equation. How about that? It's a little different. So example 3, I'm doing a very generic graph right now, okay? Let's draw this guy out. I'm going to do this. Okay. The vertex is going to be 2, -3. And this point over here, I'm going to have that be 0, -1. Okay? So once again, this is my vertex. And then this is just a random point that I found on the grid. Okay? Here's a good official way. So come up with the equation. That's usually not how it's phrased, but hey, we're going to have some fun with it, okay? Come up with the equation for this graph here. Now, I want to be very clear. The vertex, you can always figure it out, right? This point, I picked it on purpose. Now, you could pick any other point to do this, okay? There's a reason why I picked it, and you'll see. I would like to write this in vertex form. I know what H and K are. H and K are the vertex, right? No problem. There's only one value left I don't know, and that's A, right? I need to know what A is, then I can write my entire quadratic equation. Well, how can I find A? Well, here's what I could do. I know what the vertex is. I know one of the points that's on the line that makes it work. If I plug these numbers into here, the only number I have left is A that I don't know. So I could solve for A, and then I know what the scale factor is, technically, in a way, right? Like, what's the vertical transformation that's happening here? Does that make sense? Okay. If you'd like to label this, you can. There's my H, there's my K value, here's my X, and here's my Y value. So here's my original that I'm working with. Okay, I want to write my equation in that format. I'm going to go ahead and substitute these values into here. Y is -1. I don't know what A is yet. I'm trying to figure it out. X is 0. H is 2. And then K is -3. I'm not going to put plus -3. I'm going to put just -3 there. Okay? Do you see why I picked this guy as my point? Like I said, I could pick any point that's on this curve. But 0 is a nice way to calculate this, huh? Makes this a lot easier. -1 equals, now, 0 minus 2, -2. Square it, I get 4. And 4 times A gives me 4A. And then put -3 afterwards. We're almost done. Getting close, really close. Solve for A, I'm going to add 3 to the other side. I get 2 equals 4A. Divide those sides by 4. Now, I get 2/4 when I do this. I want to reduce it to 1/2. This guy right here has a vertical transformation. It is being compressed by a factor of 1/2. Okay? Now, let's put this together. My equation is going to be 1/2 x minus 2 squared minus 3. This guy is this guy over here. Pretty incredible, isn't it? And like I said, you can pick any point on this graph to plug into here because those points work for this guy. You can't just pick a random point that doesn't lie on the graph because then it's like your equation isn't going to match up to the points, right? This can be written like this. I want to be very clear on that. You can write this in a standard quadratic formation. All you have to do is what? Square this binomial, multiply by half, subtract 3, and you'll get your original equation. So you could write it in this format, but both of these are acceptable. This one's a little bit easier because 1, it's based on what vertex form, but 2, it's a lot easier to compare it to the graph because you could say, oh, the transformations of this guy is to the right 2 and down 3. Okay, that's good. We can do that. All right. One more? Can we do one more? Please? Can we do one more? These are fun. Let's do one more. If you want to quit the video, you can. If you don't want to do another one, that's okay. All right, so I'm going to move this out of the way. Let's erase this guy over here. Okay. All right, so example 4. So my parabola is going to look like this. My vertex is -1, 2, and I'm going to pick this point here, which was 0, -1. Okay. So, same instructions. Come up with the graph. That's what we're going to do. Okay. Put this over here. Now, this is my vertex, which is the h and k value. This is my x, and this is my y value. I want to write it in this format. And once again, I picked this point, that's on the graph, by the way, because it has 0 in it, and it makes the calculation simpler. But I could pick any other point and still come up with the same conclusion. I'm going to go ahead and substitute. I get -1 equals a, then x. Now, we got to be careful here. This parabola went to the left 1, right? If I'm going to the left 1, that has to be what, a positive, huh? Be a +1. Now, if I plug -1 into here, can you guys see you're subtracting a negative, which is positive? Another way to confirm that. And then +2. Okay. Oh, you're probably screaming at me, Mr. McCullough, that should be a 0. You're absolutely right. I heard you. Honest, I heard you. See? Now we're going to simplify. We have -1 equals 1 squared is 1. 1 times a is just a. And then +2. Subtract to the other side, we get a to be -3. Now let's put it all together. Y equals -3, x plus 1 squared plus 2. Remember, the point is to help me to figure out what the a value is, right? That's why we're doing this. The reason why I can't just jump into this, guys, is because I need to figure out if there is something going on here. And there is. Look at the graph. See how it's being reflected? So you know it's a negative. And you can, well, this is just a hand-drawn graph, but you can see that it's a little bit narrow, right? So therefore it's being vertically stretched just a little bit. Imagine like some shoelaces, right? You're pulling on shoelaces really tightly. Okay, that's what this is kind of showing. So this is matching this guy right there. Okay? And we're on the almost 25 minutes. Not bad. We were able to get the entire lesson done in one video instead of 2 parts. Okay? But this is transformations. Hopefully this helps. Hope you guys are doing well. And hey, until next time, we have one more lesson with quadratics, sadly. There's a lot to do with this. But until next time, guys, I will see you all in the next lesson video.